All right, so here's a study guide, a review of what we've done so far. After this, you're going to take a test, and you can use the study guide to help you. So first, let's do this together, going over all the content that we have so far on beginning of calculus, which is understanding limits, how to find them, evaluate them, and derivatives. All right, first thing, notice this graph. Can you write the end behavior as a limit? So if I want to write as limit as x approaches negative infinity of f at x, that's the left end. And where's the left end going? To negative infinity. And the other side, the limit as x approaches positive infinity, where's the right end going? And that's also going down to negative infinity. Let's try this one. What's the limit as x approaches negative infinity of this function? Where's the left end going? And you can see here it's flattening out to a y coordinate. So it's not going up forever or down forever. What is that number? And that number is positive 1. Same thing for the right side. Where is the right end going? So if I look at the right end here, it's flattening out to what y coordinate is it approaching? So we say the limit as x approaches positive infinity of f at x equals positive 1 on both sides. That's a horizontal asymptote. Number 3. How about the left end and the right end? So if I look at the left end, this is what I'm looking at. That's definitely pointing up to infinity. When I look at the right end, that's definitely pointing down to negative infinity. So the ability to write the end behavior of a function using limits. Next, I first taught you how to evaluate a limit using a graph, Desmo. So that's what we're going to do right now. Do you remember using Desmos as a way to understand the limit? So the first one is the limit of negative 3x plus 16. So if I go to Desmos and I type in negative 3x plus 16, I want to know as x approaches 7. So if I look here, as x is approaching 7, off the graph, as x approaches 7, from the left side and the right side, the answer is negative 5. I'm just going to stay here on Desmos. So the next one to type in is 3x subtract 4 over x squared. And then I want to look at what's happening as x approaches 0 from the left. So if I look here at 0, you can see at 0 there's an asymptote. On the left and right, they both are going in what direction? So the closer the function gets to 0, what's happening to the y coordinate? And the answer is it's going to negative infinity. So I'm going to write that answer down. You do too. So number 5, what's the answer? Negative infinity. Next one, number 6. I'll go back to my sheet once I've done a few of these on Desmos. So 8 divided by x squared, subtract 4, and look off the graph. And the question is, as x approaches positive 2. Well, here we are at positive 2. The right side goes up forever. The left side goes down forever. So that means this does not exist. They don't agree at positive 2. The left and the right side must agree. So again, we're using a graph to do this. So again, the next one is x squared plus 3x subtract 4, x squared plus 2x subtract 3, and it says x approaches negative 3 from the right. So if I look at negative 3, there's an asymptote there. It goes up forever to the right and down forever to the left. So, but from the right, that little plus sign, what's the right of negative 3 doing? It's going up forever. So the answer here is positive infinity. Number 8. So now I want to know the limit, and this one is 3x plus 12. The denominator is absolute value sign, x plus 4. And I want to know as x is approaching negative 4 from the right. So here's negative 4. So from the right, what's the y coordinate? And you can see the y coordinate is staying right at positive 3. this blip here, that part up there is an error on Desmo to try to be able to graph this. That is not a part of the graph. Neither is this part. This vertical line part is also not there. So we have two lines, and exactly at -4 there's a jump. But from the right, the y-coordinate is +3. So that's the answer. All right, let's look at number 9, again from the graph. So from the graph, what do we have? The absolute value of 5 minus x, the denominator 3x subtract 15. So again, as I'm approaching 5, now if I look here, as I'm approaching 5, you can see where 5 is. There's a jump at 5. And when there's a jump at 5, the right side and the left side don't agree at the y-coordinate. So that jump means the limit does not exist, just like mean girls. Number 10. And then I'll let you look at the sheet here. So number 10, now we have a trig. So it's 3/2 cosecant 2x, and I'm going to change the scale, and I'm just going to change the scale. I'm looking at 3 pi over 4, so I'm going to change it to pi over 4. So let's look at it. So I'm looking at really +3 pi over 4. That's 1, 2, 3. That's right here. At +3 pi over 4, you can see what's the answer here. So from the left and right, what's the y-coordinate? And the answer is -1.5. And you get it right off the graph. There are asymptotes on this graph, but at 3 pi over 4, it's a point on the graph. Not a hole, not an asymptote, so the y-coordinate is what it is. So the function value and the limit is the same answer. Let's try the next one. So the next one is sine, and it's 2 over x squared. So what's happening around 0 here, can you see how it oscillates up and down right around 0? That oscillation going up and down means the limit does not exist as it approaches 0 because of the oscillation. All right, 2 more that we use our graph in Desmo with. So the limit, oops, I'm just going to type it in, tangent 1/2 x. And what I'm looking for is as x approaches -pi from the left. So -pi in the left, what's happening to the left? And it's going to infinity. So exactly at pi is an asymptote, but the left is going up forever, and on the right, it's going down forever. All right, one more. This one is piecewise, so we'll type them in. We'll just type them in separately. So for 1, we're going to write in 4 subtract 5x. Oops, that's not 4. 4 subtract 5x space. I'm going to use this, and I'm going to put in restriction. X is less than -1 and close it. I'm also going to change the scale so it's no longer radians, so I'll just change it back to 1. Maybe I need to type in this here. Where is it? So if I type negative, is it down here? Is that +9? There it is. Up there. Okay, then I'm also going to type in x cubed, and that's +6. And then again, I'm going to use the fancy parentheses and then type in x is greater than or equal to -1. And then what I want to know looking off this graph is as x approaches -1 from the right. So -1, now the black is from the right. So as I go from the right and approach -1, what's the answer at -1? So as you're approaching -1 from the right, the answer is +5. If it's from the left, the answer would have been the y-coordinate there, which is 9, even though there's a hole. If you just said, does the limit exist there, like a two-sided limit, the answer would be no, because of the jump. but a one-sided limit on the right, we can get the answer. All right, let's go back to this so you can see my answers. So 4 and 5 and 6 and 7, 8, 9, 10, 11, 12, and 13. So those are the answers, being able to use a graph to find a limit. All right, next page. Now we're going to evaluate this using substitution or using algebra techniques like factoring and the conjugate and so on. So step one for a limit is to see if the function value does equal that limit value. That means it's continuous. Now this is a polynomial, so it's continuous everywhere. So you can just simply plug in 1 to get your answer. That's what I'm going to do. So plug 1 in. You can use a calculator if you like. And the answer is -3. So there's no jumps, no asymptotes, no holes. It's a polynomial. It's continuous everywhere. So the function value and the limit value are the same. And that's a calculus definition of continuity, where the limit and the function value are the same. All right, number 15, substitute in. And evaluate. That's 3 squared, ultimately. 9 take away 5, so the answer is just 4. So again, at its most basic, to evaluate a limit, you evaluate. You just plug in. When that does not work, you might have to factor, conjugate. You might have to think through if there's a jump or asymptote at that number. So again, I'm going to substitute in. If I got an answer that was undefined or indeterminate, then I would have to do something else. So I'm going to substitute in. If you simplify it, it's -13 over 25. Easy peasy. Again, I'm going to substitute in. So I'm going to plug in -6. So that's 1 plus 24, the square root of 25, 5 plus 9, and that limit is 14. So pretty simple when all you have to do is substitute in. Next, if I substitute in here, good unit circle practice. So I'm going to simplify this. That's -1/4, take a plus 3/4. So 3/4, and you take away a quarter, that's 2/4, or 1/2. Then on the unit circle, where is pi over 2? It's at the top. And what's the y coordinate at the top there? And the answer is just +1. The value of secant at 2 pi, so plug in 2 pi. You get 3 pi. On the unit circle, 3 pi and positive pi are coterminal. So that's the point they share. Secant is the reciprocal of the x coordinate there. Well, the x coordinate there is -1, and the reciprocal of -1 is -1. Number 20. The step number 1 here is substitute in. But if you do substitute in, what answer do you get? So let's do that. So I want to plug in -1. I want you to notice that when you do plug in -1, you get -1 squared plus 1 take away 42, so it's not indeterminate. -1 squared minus 1 -1 plus 6. So in the numerator, you get 1 plus 1, so that's -40. In the denominator, you get 1 plus 7 plus 6, that's 14. Is that right? -40, 13, 14. Make sure I'm doing my work correctly here. So -1. Oh, this one I did a mistake on. So I knew I made a mistake somewhere. So this is actually -43 plus 1, which is -42. There's the mistake. Divided by 14. So if I put that together, the answer is -3. So again, these are just by substitution. Here, what happens when you plug in 8? And it's okay to use a calculator. What I do know, especially looking at the denominator, is that the answer is not indeterminate. It does not give you an answer of 0 over 0. So if you did use your calculator and simplified it, 21 gives you the answer 4. So when you do your test on this, yes, use Desmo's calculator, use your notes, use the study guide, and then go to the video to see how well you did. Again, substitute in. Now I see a challenge here. 5 take away 5 gives me 0. 5 plus 4 is 9, and the square root of 9 is 3 take away 3. This is indeterminate. So because it's indeterminate, I have to either factor or do the conjugate. So I need this case, because we have a square root, we're doing the conjugate. So the conjugate of the square root of x plus 4 take away 3, we're going plus 3, top and bottom, when we multiply. So as I do the limit as x approaches 5 here, the numerator I'm going to simplify. So first times first, that just undoes the square root, so it's x plus 4. Negative 3 times 3, that's negative 9. The denominator, I'm just going to put them beside each other. So as you do that, I want you to recognize that when you combine like terms, 4 take away 9, that's negative 5. So this is x take away 5, which then divides the whole out there. And what I'm left with is a 1 in the numerator, and then plug in 5 in the denominator. And 5 plus 4, 9. Square root of 9, 3 plus 3, and you get the answer 1/6. Let's try this again for 23. Step 1 is to plug in 3. Plug in 3, 0. Plug 3 into the denominator. You also get 0. This is indeterminate. So how are we going to resolve that is to use what's called the conjugate. So the square root of 3x minus 5 plus 2. The square root of 3x subtract 5 plus 2. Then the numerator, I'm not going to simplify. I'm just going to put them beside each other. The denominator, I'm going to go first times first. That just undoes the square root. Last times last. And what I have in the denominator is 3x take away 9. Now, we're not quite ready yet. So I need to factor the denominator a little bit more. So when I factor out the denominator, I factor out a 3, and you have x subtract 3. We have 3 take away x, the square root of 3x take away 5 plus 2. I want you to notice that these are opposite factors. So they do divide out, but opposite factor leaves you with negative 1. So when you plug in 3, you get 9 take away 5, 4, the square root of 4, 2 plus 2, but it's not a positive 4, but a negative 4. And what I'm left with in the denominator is 3. So the answer is negative 4 over 3. All right, next page. Now, these questions have to do with infinity. So when it has to do with infinity, we're talking about end behavior. And when we're talking about end behavior, what I'm looking for is the power terms. So what happens as x approaches negative infinity? What is the power term here? Which one has the biggest exponent? That's negative 6x to the 5th. So I have a negative power term. The right end goes down. An odd exponent. So the left end goes in the opposite direction. It's asking for the left end behavior. So the answer here is infinity. The limit as x approaches infinity. What's the power terms here? Since we have a rational, we have 2 we need to look at. Oops. So when I look at that, the numerator is 6x squared. The denominator is negative 9x squared. Notice the x squares divide out, and you're just left with the answer negative 6 over 9 or negative 2/3. So when you're left with a constant, the right and left end are just going to that constant. It's a horizontal asymptote. In this case, it's negative 2/3. 26. Again, I want to find the limit as x approaches infinity, and I just want the power terms. That's negative x cubed over 3x squared. What I want you to notice is when you simplify this, You have negative 8 over 3, that's in front. The x squared makes the x cubed just an x. So what you have here is a slope of a line that's negative. So what is a negative slope line? I just want the end behavior. So negative 8/3 x, there's the line. And I'm looking for the right end. So where's the right end going? And the answer is negative infinity. All right, last one with the end behavior. So the limit as x approaches negative infinity, the power, that's x squared over 2x to the fourth. Simplify it. Actually, we don't even need to simplify it, but I will. Because the bottom is more powerful, whenever the bottom is more powerful, then the function is approaching 0 at both ends. So that's using the power term and end behavior to be able to evaluate a limit. Now, 28 and 29 are sequences. That's Calc BC. That's not us right now. So 28 and 29 you can cross out. Turn the page. Now we're going to talk about derivatives. Now remember, first we talked about tangent lines. Then we had our saying really what we're finding is called a derivative. So when you find the slope using one point, that's called the slope of a tangent line. And that is called a derivative. It's one of the definitions of a derivative. And remember, to find the slope of a tangent line, you have to use limits. So use the slope formula, but you do that finding limits. So that's what we're going to do. So if I want to find that slope, so find the slope, it's the limit, and we actually have an x value, so I'm going to use that. The value is x approaches negative 3, and we're going to use the short form. So that's f at x, which is 3x squared plus 5x take away 7, subtract f at negative 3. We already have the answer, which is 5. And then the denominator is x subtract negative 3. So that's the short form when you know the x coordinate that it's approaching. If you want the generic one, then you would have used h. So I'm going to simplify this. So that's 3x squared plus 5x take away 12, x plus 3. So next I'm going to factor this. I'm going to use the fact that the likelihood of x plus 3 dividing out is high. So I'm going to use x plus 3 to help me find the rest to see if it works rather than a longer way to factor this. So assuming x plus 3 divides out, and if it didn't, then it didn't, but we're going to go with that first assumption and then go from there. X times 3x is 3x squared. And 3 times negative 4 is negative 12. And then 9 take away 4, it does fit. So x plus 3 divides out. Now plug in negative 3. And the slope that I was looking for when you plug in negative 3 is negative 9 take away 4, which is negative 13. So that's step 1. Then the next step is, what's the equation? Now I'm not going to put it in slope-intercept form. I think that's silly. Just write the equation. So it's y equals, what's the slope? Negative 13. What's the x coordinate? Change the sign. What's the y coordinate? Keep the sign, and you have that. If you really needed it in slope-intercept form, you would distribute combine-like terms, and you could do that. But I want you to be comfortable with that. That's called the HK form of a line. All right, let's look at 31. We're given an x value, so we're going to use it. So to find the slope, it's the limit as x approaches 2. So what's the slope as x approaches 2? So what's the function? Negative x cubed plus 6x minus, plug in 2, and we already got the y coordinate, which is 4, and then the denominator is x minus 2. Now, what you're given here in the numerator, step 1 actually would be, I'm going to use my calculator to factor it, because it's a cube, but it's not one where we have a formula. It's one where you'd have to use rational zero theorem. It would take a lot of work. I want you to use your calculator and just be done with it. So I'm going to use my calculus calculator that you're going to get one day, hopefully, and factor it. Now I am going to factor out the negative out of the x cubed, because I want that power term to be positive. So that just changes these signs here to negative 6x plus 4. So let me use my calculus calculator to do it. So when I do that, Let me just clear this. There we go. My goodness. Okay. Give me one moment as I clear my calculator. For some reason, of course, right now on video, it's going to take like forever to clear. I tried to clear the history of it, but it wouldn't clear what I really needed to clear. So here we go. Could open up a new document. All right, so this is what it looks like. You don't have this yet. You might have it if you're in stats last year. So I'm going to press menu, algebra, and factor. And I'm just going to type in x cubed. And it's x cubed subtract 6x plus 4. Oops. Make sure that this, so it's subtract 6x plus 4. So there you go. That's what you're left with. X minus 2. I'm going to write that down here. So the limit as x approaches 2. You got x minus 2, you got x squared plus 2x minus 2. You could also have used synthetic division. Let me just show you. Assuming this would be true, as x approaches 2, that it's indeterminate, positive 2 is a 0, we could have also done this without a calculator. For those that would care, 1x cubed, 0x squared, negative 6x, and 4, and then do the work for synthetic division. And you get the same answer. So you get x minus 2, x squared plus 2x minus 2 without a calculator. So there you go. Notice that the whole divides out. Now plug in 2. So what's the slope when you plug in 2? 2 squared, 2 times 2, minus 2. So that's 6. Oh, and there's a negative in front. Remember? I forgot that little negative. So because there's a negative in front, when you plug in, that's going to be a negative 6. So now write the equations, negative 6. And then we take that point, so we change the sign and then keep the sign. And there's your equation of a tangent line. All right, number 32. Find the derivative using a limit, then evaluate it at negative 2. So we're going to first find it using a limit. We're going to write this down with h this time. And the formula is f at x plus h minus f at x over h. So in this situation, we're going to plug in x plus h. For x, we're going to subtract, use parentheses. Put in the function, negative 2x squared plus 9x. And then we just got to do a little bit of algebra. I know it's a little heavy lifting, but we can do it together. So we're going to combine like terms. Well, first I'm going to expand this. So x plus h squared is x squared plus 2xh plus h squared. Then we have 9x and 9h. Then we have plus 2x squared, subtract 9x. Now it's going to get easier. So anything that doesn't have h in it, it's going to simplify. So negative 2x squared and plus 2x squared, they're gone. Negative 4xh, that stays. Negative 2h squared, that stays. 9x and negative 9x go, and we still have a 9h right there. So the limit as h approaches 0 of what's left over here. So we're going to divide out an h. So h divides out of everything. So when I factor out an h, I get negative 4x minus 2h plus 9. The h's divide out, plug in 0, and you have the derivative. So the derivative is negative 4x plus 9. which you could have done with derivative shortcuts. Then what's the value of the function at -2? So plug in -2, and you get 8 plus 9, which is 17. All right, let's try that again. Then we'll be able to use shortcuts in a moment. But we need to know that you have this skill. Can you find a derivative using limits? So the limit as h approaches 0. Now, first you plug in x plus h. I'm just going to do that immediately. Subtract the function, which is just write down what the function is, all over h. I need common denominators, so I'm going to make the denominators the same. That means the first denominator needs x minus 1. So we have 4x plus 4h, and we're going to multiply that by x minus 1, top and bottom. Then the second denominator needs x plus h minus 1 to get common denominators, and that's all over h. We got some lifting still to do here. So the limit as h approaches 0 of this, so I'm going to multiply this out. That's 4x squared. That is negative 4x. I'm just foiling. 4xh. And then negative 4h. Then, again, multiply this out. Negative 4x squared. Again, if you did this right, only that has an h left over. Should be left over. Everything else is going to eliminate. Negative 4xh plus 4x. And that's all over x plus h minus 1 times x minus 1, and that's all over h. A mess. Let's clean this up. This is the toughie, but we'll do it together. So 4x squared minus 4x squared. I get positive 4xh, and I get a minus 4xh. I have negative 4x plus 4x. So what that leaves me with in the numerator is negative 4h. That's what I have left over. That's over x plus h minus 1, x minus 1. Then I'm right away going to multiply times the reciprocal. So the h's will divide out. Now I plug in 0. So when I plug in 0, I get negative 4. And then I get x minus 1 squared. So when I plug in 0 here, I get x minus 1 times x minus 1, which is negative 4 over x minus 1 squared. Make sure I did everything correctly. Then, to find the derivative at negative 2, I get negative 4, negative 2 minus 1 squared, so that's negative 4 over 9. All right, let's keep going. 34. Now we're going to use shortcuts. So no more limits to do this as we end here. So can you remember the power rule here? And we're not going to simplify if we have to. It's here. So 3 times 4 and subtract the exponent. This appreciates why we don't do limits, right? 2 times negative 3, subtract 1 to that. 7x is just 7, and the derivative of negative 11 is 0. Done. Again, so much better, right, than doing limits. The derivative here, 7 times negative 5, subtract 1 to the exponent. 5 times 2, subtract 1. 2 times negative 3, and then the derivative of negative 9, 0. Simple power rule. Sometimes you have to write this with the power so you can do it. So write this to the 1/2. Now, when you do the power rule, it's going to be 1/2 times 1 in front. That's 1/2. Subtract 1. So 1/2 take away 1 is -1/2. This one actually has a hook. So what's the derivative of just the base? So the derivative of 3x plus 8 is just 3. So it needs that. That's called the hook or the chain for what's called the chain rule. So that times 3 needs to be included. Number 37, using derivative rules. First of all, write it with a power. So you have 15x times x, and the power would be 3/5. Next, I'm going to combine them together. I have not done the derivative yet. So power rule, exponent rule, when the bases are the same, you multiply, you add them together. So that'll be 5 plus 3. So that's 8/5. Now take the derivative. So now it's 15 times 8/5 and subtract 1. So 8 take away 5, that's 3/5. If you like, 5 goes into 15 3 times, and 3 times 8 is 24. X to the 3/5. Be able to write it as a power and then doing the power rule. Here we're going to use the quotient rule. So to find the quotient rule, a healthy fraction line, it's the bottom times the derivative of the top, subtract the top times the derivative of the bottom, and then take the bottom and square it. Done. Same thing here. I want to do the derivative using the quotient rule. So using the quotient rule, it's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then take the bottom and square it. $40. By the way, for 38 and 39, you could have taken it and written it as two fractions, simplified it, and done the power rule there too. Both are the same answer. All right, number 40, the product rule. So the product rule is the first times the derivative of the second plus the second. See if I have enough room here. Times the derivative of the first, and that's it. For 41, again, the power rule, make sure I have enough for the product rule. The product rule is the first times the derivative of the second plus the second times the derivative of the first. Just do a simple power rule here. Remember, the derivative of 3 is 0. So you have 3x squared plus 4x. Before you know it, taking the derivative is like going 5 plus 5. You can do this. 42. Again, I'm going to use the quotient rule and not simplify. So that is the bottom times the derivative of the top minus the top times the derivative, 6x of the bottom, and then the bottom squared. That's a 6x. One more time with the quotient rule. We'll get this. It's way better than limits, right? The bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Know that the derivative of x is 1 and negative 11 is 0, so that's why it's just 1. Know those rules, right? All right, here's the last page before you have your test, and you can use this study guide and calculator in your notes and all of it. So the number of internet subscribers can be represented by that equation where x is the number of years since 95, and do you know the AROC compared to the IROC? So first of all, to find the AROC, it's algebra, just y2 minus y1. So we're going to use our calculator, or I'll do the calculating for you, but what's the setup? So from 97 to 2000. So x is the number of years since 95. So first, 2000 from 95, that's 5. So we're going to go f at 5 minus 1997 from 95, that's 2 years, and then 5 take away 2. So f at 5 minus f at 2, 5 take away 2. So when you substitute in and then divide by 3, you get an approximate answer of 153.9. Now we have a unit here. This is in million per year. So the rate of change, right, is an increase of an average increase of 153.9 million per year. B, what's the instantaneous rate of change? Exactly in 1998. Now to do that we need to know the derivative. So the derivative is just the power rule. So 2 times 16.8, that's 33.6x, and then 36.3 for the derivative. Plug in 1998 from 95, that's 3. So plug in 3 into this, or there's an x, use a calculator if you want, and you get 137.1. Again, it's a rate, so it's a million people per year. So what's the rate exactly in terms of it? And again, at year 3 after 1995, what we know is it's increasing. And that's the exact rate, instantaneous rate, exactly at 3 years. 45, the profit per day of a certain computer part can be represented by that function, p at x equals and so on, where x is the sales price. Find the AROC. So let's do that. So what does AROC equal in this case? So in this case, it's between the profit sales of 100 and 400. Now, be a good reader. X is the sales price in hundreds of dollars. So 400 would really mean we just plug in 4. In 100, we plug in 1 because it's already in hundreds. And then 4 take away 1 here. So use your calculator and plug in. And you would get the answer 8. Now that means the answer 8 is $800 per day. So that's the average profit with sales between 100 and 400. The IROC, I need to know the derivative of p at x, and that's negative 3x squared plus 8x plus 9. And then with the derivative, I plug in 250. So that's 2.5 in hundreds. And then when you plug in 2.5, you get 10.25. So that means in hundreds, that's $1,025 per day of profits. Exactly, for instantaneous. All right, 2 left. A rock is dropped from a height of 200 meters. The rock's height in meters after t seconds can be represented by this equation. Find the average velocity. That's like a rock. So between 1 and 3 seconds. So I'm going to plug in 3, I'm going to plug in 1, and then I subtract those x values. That's finding the slope between those 2 points. So if you plugged in 3, if you plug in 1, divided by 2, use your calculator, Desmo, so you would get negative 19.6 meters per second because it's a rate. That means that that's the rate it's falling. The negative is falling. This means the speed that it's falling at. For the IROC, I need to get the derivative first. So the derivative of that is 2 times negative 4.9. That's negative 9.8 t. And then the derivative of 200 is 0. Then you just plug into that instantaneous 3.5 into that equation. So negative 9.8 times 3.5. And you get negative 34.3 meters per second. So exactly at 3.5 seconds, the speed of the object is this, and this tells me it's falling, the negative. All right, last one, 47 for your study guide. The height of an object thrown in the air from a platform 5 feet above the ground is represented by this equation, for t is in time in seconds, and h is in feet. Find the AROC, the average velocity. So that's just algebra. And it's between 0 and 1.5. So we're first going to plug in 1.5, subtract, plug in 0, and then use those same numbers in the denominator to find the slope. If you use your calculator, you would get 4 feet per second. That's the speed of the object. average speed between 0 and 1.5 seconds. To find the AROC, I need to find the derivative of that equation. The derivative of that would be negative 32t plus 28. So again, using the shortcut power rule for the derivative. And then in the question it says at exactly 1 second. So then plug in 1, and you get negative 32 plus 28. That's negative 4. That's feet per second. So the speed of this object is 4 feet per second. This just tells you that it's going in a downward direction exactly at that time. All right, Mr. G Math over and out. Thank you for doing your work, and until next time.